So here's an example of two infinite sets. X is greater than 3 is an infinite set. X is less than or equal to 10 is an infinite set. There's an infinite number of numbers that are bigger than 3. There's an infinite number of numbers that are less than or equal to 10. So our first step was to identify colors to each of these sets. So I'm going to call the first set my blue set and the second set my red set. I'm going to label my important numbers on the number line in the right order as you go from left to right. So the smaller number comes first, the bigger number comes second. So I'm just labeling these numbers on here, and maybe this will be part of my answer, maybe it won't, but these are just the important values. Now above the number line, and this is important that we do it above the number line, because we're kind of laying out our scratch work is kind of what we're doing. The actual number line itself should be our final answer. So to lay out our scratch work, we're going to take x is greater than 3. X is greater than 3 would be an open circle at 3 and everything larger than that. And notice that I'm extending that line all the way to the end. I'm not just doing a small line with an arrow. And this is important to be able to visualize this problem properly. Then I also have x is less than or equal to 10, and I'm using red for this. So since I'm allowing equality to 10, I'm going to use the closed circle to say I'm including that. And less than means everything to the left of it. So this is my scratch work. Now I need to use this to figure out what it is that I need to be shading for a final answer. What I want you to visualize here is that we broke the number line up into 3 chunks. We have the chunk that's to the left of 3. We'll call that the leftmost chunk. We have the chunk that's in between 3 and 10. We'll call that the middle chunk. And we have the chunk that's to the right of 10. We'll call it the rightmost chunk. We need to look at each of these chunks, and we need to say, do they satisfy the problem? Our problem at hand, and here's how to make it as simple as possible. Ignore the x's, ignore the numbers, and just look at colors. Blue and red. That's what our original problem says. Blue and red. My final answer is anywhere that I have blue and red. So if I look at my leftmost chunk, I can say in this leftmost chunk over here, do I have blue and red? And the answer is no. I only have red. So then I look in the middle chunk and say, do I have blue and red? Why, yes I do. Because I do have blue and red, I'm going to shade this interval. Then I'm going to look at my rightmost chunk and say, hey, do I have blue and red? Nope, I only have blue. So that's not part of my final answer. Now I do have a little more work to do. I have to look at the endpoints themselves. So at the endpoints of 3 and 10, I need to figure out what's going on. So at 3 itself, do I have blue and red above? No, because blue has an open circle. So for that reason, I need an open circle here at 3. Over there at 10, though, I do have both blue and red directly above it. So I'm going to use a closed circle there. This is the graphical interpretation of my answer. But I also want interval notation. So I need to go from this graph to write it in interval notation. And I do that by saying it's everything from 3 to 10. We always go left to right. Order matters. And then we use the right symbols. So at 3, I'm not including that point, so I use a parenthesis. At 10, I am including that point, so I use a bracket. And that's the answer to this example, is from 3 to 10, not including 3, but including 10.